My name is Frederick and I work here in R&D Test System as a project manager. The main purpose of this project is to supply a test load unit for a sub-component for the wind turbine industry.
My name is Simon Christensen and I'm a system engineer here at R&D Test Systems. As a system engineer, we are responsible for the safety system, the hydraulic design and the control system. On this project, one of the biggest challenges was to formulate the kinematics such that we were able to predict the loads to apply on the test unit. In essence, the TLU is a parallel robot, meaning that a bunch of actuators act in parallel with one another to apply loads to a unit. And in that, to predict the loads you want to apply to the unit, you need to formulate kinematic equations that links the actuator loads to loads on a test device. During the development of the kinematic equation, we use simulation models quite a lot. And we do so in order to test that our algorithm works before we actually do any test on the real system. Part of the control is to develop a human-machine interface, also called a HMI. Through this interface, you can align the load unit with your device under test and subsequently control the loads applied to the device under test in an intuitive manner. So the purpose of the kinematic model or kinematic equations is to relate movements of the blue part here, which could be the device under test, to actuator movements or forces. So we want to apply bending in a direction. We can use the kinematic equations to relate that to movements of the actuators.
This test load unit is able to validate these sub-components for the wind turbine industry, and with this they're able to test in a very short amount of time the sub-component to prove to the wind turbine manufacturer that these components are able to withstand 25 years at sea, and they're able to do this with a span of 2 to 3 months.